Okay students, so let us solve the next problem. So unit vector normal to the given surface, right? So unit vector which is normal to the given surface, right? So let me consider a surface here. Okay, so let me consider a surface. Let phi of x, phi, z, it is a function of z, that is equal to the constant c, okay, be the given surface. Now the unit vector which is normal to this surface. So first of all, the vector which is normal to the given surface is gradient of phi, right? You know what is the gradient of phi? It is I into dou pi by dou x plus j into dou phi by dou y plus k into dou phi by dou z, right? So we need to calculate the unit vector which is normal to the given surface. So the unit vector which is normal to the given surface is denoted by n cap, that is given by the gradient of phi divided by its magnitude. Okay, so this is the formula. Now let us solve the first problem. So now look at the first question. We need to find the unit vector which is normal to the surface. So here the surface is given. Also look at the next question. So we need to find the unit vector which is normal to the surface, x square into y plus 2z equal to 4. So let me call it as xi. So that is x square y plus 2z. Okay, so that is we have to consider the function of x, y, z only. Just leave this 4. Okay, so calculate the derivatives here. Dou z by dou x, directly we can do this. Here y is constant, so y into the differentiation of x square is 2x plus the differentiation of z with respect to x is 0. So this is nothing but which is 2x into y, and the partial differentiation of xi with respect to y, that is equal to, here with x is constant and z is constant, so x square is constant, the partial differentiation of y with respect to itself is 1 plus the partial differentiation of z is 0, so it is x square, and dou z by dou z, so that is equal to, so here x and y are constant, the differentiation of x square y is 0 plus 2 into the differentiation of z with respect to itself is 1, so which is 2. So now the gradient of xi, what is that? It is I into dou xi by dou x, what is that? Which is 2xy plus j into dou xi by dou y, which is x square plus k into dou xi by dou z, which is 2. So now we have to calculate the gradient of xi at the point, so 2 minus 2 3, so 2 minus 2 3, at x equal to 2, y equals to minus 2, z equals to 3. This is I into, so 2 into minus 2, which is minus 4, minus 4 2 is a minus 8, right? Plus j into 2 square is 4 plus k into 2, so which is minus 8i plus 4j plus 2k. So now we can calculate the unit vector which is normal to the given surface. What is that? It is the gradient of xi divided by magnitude of the gradient of xi at the point 2 minus 2 3. So it is minus 8i plus 4j plus 2k. What is the magnitude of this? It is square root of 64, 8 square 64 plus 4 square 16 plus 4. We can do the simplification here. So this is the unit normal vector, which is unit normal vector to the surface, xi equals to x square y plus 2z.